Donc je vais vous parler des perspectives de désherbage robotisé.
Now I'm going to talk about the outlook for robotic weeding for specialized crops. So I'd like to thank the ITEPMI, who are part of our 85 members. They're one of them who contacted us for today, so thank you. I'm going to give you a quick presentation of the association. Who are we? We unify in a very comprehensive way people working in the machines, startups, people that are producing robots, robotic research or applied research like is done at the ITEPMI, and farming groups. We were created in 2017, and the goal is to produce and to pool shared knowledge. I'm really going to highlight that because we have working groups in place which change all the time, but in them we're going to share knowledge as much as in any institute, but we're also going to deal with issues like standards, agricultural systems which are evolving, and we're going to try to bring to the table the expertise of each and every person. Then the objective is to encourage a vision for agricultural robotics and represent the sector with the institutional level, particularly nationally. Our main actions then and our results, what's been going on for the last 4 years? Well, there is this pooling of grouped thinking, shared thinking. We have suggested to 10 different solutions to the state for developing agricultural solutions which will allow us to move forward in agroecology. And we've been able to bring out a call for tender which allowed us to test certified, EU-certified robotics with farmers, but also with cooperative groups, or even by extension or by association, certain institutes. We've written all this, we've written these measures. There was great uptake by the state. We have a budget of 20 million euro for 3 years. We're very much working on standards, certification, safeties and security with groups in partnership with Axima, which is a French union for farming machine production. We have shared stances at European level in order to try and influence the machine directives which manages construction in Europe. Robot construction. So we have a cross-cutting action. We have cross-cutting in actions in place, much as we do with energy, interoperability, many things that we could look at in a very cross-cutting fashion. And recently, and it's a bit hot off the press, the government has given us a 5-year budget running up till 2027 in order to push forward agricultural robotics so that farmers have more machines available and adapted and competitive in the field. And to that end, we have 2 different wings. We're testing machines, agricultural machines, ones that exist, and we're looking at new agricultural journeys, production methods, using flams, for example, in order to try and bring to light new prototypes. We have a robotized platform, and we want to, as we pool many of our events, we have institutes and platforms who are going to pool algorithms, to share algorithms on steering systems, platforms for software projects, for robot design. So there is an enormous part which is really pooled. And that is also why we were attributed this budget. Let's look at the members now. There are 85 members. You've got you can see them in front of you. The presidency is held by Christophe Aubé, who is the president of Green Culture, and they build robots and positioning systems. And well, he will have an enormous impact, or had an enormous impact, on the first few years of the federation. We also have equipment suppliers, perhaps with people with whom you are familiar, people in detection, intelligent AI systems, the algorithms, many companies involved, APIX, Carbon D, etc. one of our members. They produce algorithms. People who are involved in detection, and by that I mean cameras and lasers. And then you look at you can see the ITIPMA is in here. This is research and learning. You've got many universities, university bodies, institutes, campuses, labs. They're all in front of you. And I would like to highlight that we are a French company, but we're very much open to others. You can see we have Japanese and Swiss colleagues, Belgian colleagues. We're very open. And these are the producer groups. I think you're familiar with most of them. FNAM, you've got Blue Whale. So, for the resume, I'm going to talk about the crossed challenges for agriculture and the robots, what's going to happen within the next 5 years. And we're going to talk about the current solutions, which have been picked up by the FNAM and in their AgroPAMS project. And then I think we're going to try and talk about the future. Where are we going to be in 10 to 15 years? What solutions are in front of us? What can be developed? And we're going to finish by talking about what's happening in our sectors when we're mutualizing. We have a role to play. So what are the crossed challenges, the mixed challenges of agriculture and robotics? Where do the two meet? Well, you can see we want to talk about resource preservation. We want to talk about, both are interested in this, looking at the soil, erosion, quality of water. These are all issues with which we're familiar for some time now. And we can add to that now everything that's to do with energy sobriety for our transition. And in the robotic world, we can answer with an industrial aspect because many startups are not at the industrial step. So we have to take their strength from industrial groups to help them. Sometimes they can buy them, so the startup then has more means. But we still need to support them for robots. And the cost price perhaps are more adapted to this kind of demand, the demand of farmers. Then we also have to pool and cooperate, and that's what we try to do in all of our projects. And of course, we have to respect the regulatory aspect. We have some very intense debates with the state on this subject. So what's going to happen in the future in the next 5 years? We're going to open up to new energies. We have to try and develop cooperation, man with robot. Man is your friend. These are things that exist in micro-weeding. This exists in all types of solutions that are already in place. And we also have to look at agroecology. That's an area that we need to develop more tools for that. And what about our ecosystems where we have sensors in place which allow us to develop in a fruitful manner? In terms of opening up to new energies, okay, well, we're working with NEDs. They're in the association. So we're going to work with them on a project of being able to charge vehicles in the field, charging the robots in the field, thanks to the existing network. I think this is a real sore point for that. It's very, very important for the sector. We've also got to consider emerging enemies, hydrogen, etc., things that we have to take into account, renewables, methanization. We have people in the association, Senagri, who work on photovoltaic panels and energy, and also in beekeeping. There are many things that need still to be invented, so we'll have to keep looking at these emerging cultures. Well, we have to develop, when I said cooperation, man with robot, because you don't move from one to the other very quickly. In all cases, there's going to be a lot of situations when we have to explain to people that we're not trying to replace man, but we're trying to lend a cooperative hand. The robot will be there to help, and he's not going away. I've showed you the different kinds of transport, fruit transport, but what I could have shown you was the transplantation of rice. And we have a small machine that works on that is self-piloted with a GPS. And this machine is able to transplant your rice plant. You also are looking about the cauliflower harvest. You have operators working on the machine with conveyors which cut. Often, in fact, we look at what happened really at the beginning of robotics. You have the milking machines for dairy farmers. Their grandparents suffered a wee bit because they couldn't really understand this milking system that was so much easier. So that was the development. That was the start of robotic development, and it's one of the advantages now of farming today. Is this helps to reduce the arduous nature of the job for the operators and for the farmer. So there are many ideas that we will be able to develop within the framework of this great challenge. And we will work with the institutes to do this. We'll work with research, and we'll work with industrialists.
So robot tools for agroecology, well, they're not about big power. Unless we build tractors as they already exist, we just take off the cabin. It's not very high power. So we need to come up with things where power is not necessary. For example, cutting the heads of plants. We could replace a tractor by a robot because there's visual control necessary for quality. But it still could be mechanized. There are robots for beetroot that's sowing and weeding mechanically. So under cover sowing could be completely automated. There are prototypes being created. And when people say you have robots, so you need sensors, well, you can have onboard sensors and try and see the content of this and that, resistance of soil, soil mapping. So there are many things to do thanks to robotics, especially sensors. Because robotics is one of the vectors for sensors. You can see on the map all of the systems we know about. So the mix of ongoing solutions, it's about the machine work speed and the balance with workforce cost and machine cost. Because depending on the means that you spend on it, there are different intervention techniques and different weed recognition means and vectors. What works best right now is artificial intelligence weeding with detection of weeds. It works on large crops. We know it does work, and farmers have no doubt about that. We know it's developed and it works well. However, on the next developments for applications, about scouting, development of diseases, I think the farmer will, all the technicians and agronomes will need to provide farmers with information so that the farmer makes the decision. I think that's what will need to happen. Different means of detection. In terms of operator, in the AgroPAM project, there was this machine from Oliver Agro working with an operator that stands behind the tractor. We'll tell you more. It seemed quite efficient. You've got the cobot of Tutiter, and Elatec created two rotovators or rotating tools that work around the row in lavender rows. That was another solution. So these are solutions where the operator detects what's necessary, and then you have more elaborated AI solutions We're talking about tracted tools like Garford, Interrow, using AI and optical recognition. And they also have robots. And their current technique can do a lot of things. They can do 30 hectares per hour. They have a lot of algorithms on online culture, on beans, corn. This company is going to develop a lot. They're from Switzerland. They've integrated the association. They had an award at the CIMA trade fair. But these solutions cost 80 to 100,000 euros per machine. So the government does subsidize about 40% of those purchases. So there are possibilities with cooperative agriculture, for instance, or joint agriculture. If we look at the trends in vectors, from tractor to robot, there's the BIP project from Delatec. It can be used for weeding, for Nayo. It's not the Osiris, it's the last model, I don't remember what it's called. For agriculture, you have tracted tools that cost less. Citia is a local company around Nantes. HKTC is also from the region. HydroKit. And Farmdroid is working a lot on beetroot, but not only. Any culture in rows could be worked on. So things are going very fast. From prototypes to market, it takes from 4 to 8 years to develop an agricultural robot. Costs can be pretty high, especially if we're talking about robots with evolved onboard technology. You also have laser technologies that are going to arrive on the market to be marketed, maybe in 4 years or less. It will depend on the means and investments from companies. In laser, you've got carbon robotics in the US with a yield of 2 to 6 hectares per day. You also have microwave technologies. There was the ROSE challenge organized by the INRAE and the LNE, National Meteorological Laboratory, also working on microwaves. And I actually made a projection. If we want to be even more precise than this, we could actually couple this with robot arms, because they also work with electricity and laser. So to really pass or go through these phases, to get something really, really high accuracy with robot arms, maybe 2035 is realistic. That's the best we can expect. I don't know if it would be the best. Technologically, it would be the most advanced. I don't know if in the field it would be the most efficient. To conclude, I wanted to say that the map sector is playing a great part to pool resources and increase developments, accelerate developments. That's what happened with AgroPAM's project. There are partnerships between ITIPMI and the FNAMs. So we have a pilot action. We're trying to have operational solutions. That's one of the objectives. And we want to bring together research and farmers to have on-site tests, to have economic references to provide the farmers with, in terms of yield, in terms of efficiency, reliability of the equipment, and the what we want to deliver is new production methods, new design of robots, protocols of trials and testing, so that trial stations in the field are equipped with the right protocols, so we can have on-site testing. So thank you very much. Thank you, Mr. Duran.